Welcome to The Explainer. I'm seriously thrilled you're here today because, wow, we are diving into something completely mind-bending. We're unpacking the prime field architecture, specifically the Mod 30 infinite motion framework. Look, if you've ever thought of numbers as just, static marks sitting quietly on a page, get ready to toss that idea right out the window. We're going to look at the integer lattice, that massive, infinite grid of whole numbers, and we're going to see it not as some dusty collection of digits, but as a living, breathing, continuously operating machine.
Check out this quote from the source material. Arithmetic is not fundamentally a collection of numbers. Arithmetic is a collection of motions. Take a second and just let that sink in. That profound little thought. That is our true north for this entire explainer. We're taking the traditional, static understanding of math and flipping it completely upside down. We aren't just counting anymore, guys. We're watching a wildly dynamic system move, balance itself, and literally propel itself into infinity.
So here is our roadmap for today. We'll start with the boundary of 30, then move into the three threads of numbers, check out the geometry of motion, explore the symmetries of the field, and finally we'll wrap up with the Riemann critical line.
All right, let's jump right into the first part, the boundary of 30, where we set the field. Before we really get into the gears of this machine, let's define what we're actually looking at. Prime field architecture, or PFA for short, is this framework that views our infinite grid of whole numbers as a fully dynamic operating engine. Think of it less like a rigid wooden ruler and way more like a finely tuned musical instrument. Numbers here are generated through active, moving symmetries. It's a space totally defined by operations and recurring geometry.
And the absolute rock-solid foundation of all this is the number 30. Now, you might be wondering, why 30? I promise you, it's not just pulled out of thin air. It is the strict boundary condition you get when you multiply the first three prime numbers together. 2 times 3 times 5. Boom, 30. In this architecture, 30 isn't just a quantity or a tally mark. Imagine it like a clock face. But instead of 12 hours, this mathematical clock resets every 30 ticks. It creates this beautifully repeating modular structure, a boundary, that basically kicks our entire mathematical engine into gear.
Moving right along to our second section, three threads of numbers, where we partition the field.
So, under this framework, every single integer falls neatly into one of three continuous fibers. Picture three distinct lanes. First up, we've got P1. This is our prime spine, holding numbers like 1, 7, 11, 13, 17, 19, 23, and 29. Then there's P2, which just elegantly sweeps up all the even numbers. And finally, P3, which carries the remaining odd numbers, stuff like 3, 5, 9, and 15. Together, they perfectly, exhaustively partition the entire field of 30. No number gets left behind.
Let's break down exactly what each lane is doing, because it's actually super elegant. P1 is the rock star here. It is the prime candidate fiber. Any prime number greater than 5 is absolutely forced by strict mathematical law to show up in this specific lane. P2 acts as the steady heartbeat, right? It provides pure, even recurrence into infinity. But P3 is arguably the most fascinating of the bunch. It's the odd audality carrier, and secretly, it holds this crucial seam at the number 15. We're going to see in just a minute how this hidden seam acts as the ultimate grand balancer for the whole system. Okay, next up, the geometry of motion. Let's see how things actually move through this field. Think about the spacing mechanism in that P1 lane. There is a very precise repeating gap sequence happening. +6, +4, +2, +4, +2, +4, +6, +2. And why is this a big deal? Well, it proves that primes don't just pop up out of random, unpredictable chaos. No way. They are governed by an intricate, relentlessly repeating engine. This spacing law is essentially a built-in rhythm pulsing endlessly through our mathematical clock. See, in this framework, multiplication isn't just about finding a simple product like we learned in grade school. It's actually a form of structural transport, and it happens in 4 true motions. First, it forms the boundary, that 30 we talked about earlier. Second, it traverses the fibers. Third, it takes that +6, +4, +2 gapping rhythm and basically scales it up. And fourth, it forms what is known as a root hierarchy. Let's zero in on that last step for a second. This brings us to a massive, game-changing revelation, the no-collision law. Basically, every generated product has one and only one structural origin, and it starts exactly at its least root squared. So, for example, the prime 7,
It starts producing its hierarchy strictly at 49. It claims absolute, undeniable ownership of that composite. If a larger prime also happens to divide a number, it doesn't even matter. The smallest prime holds the structural title, so to speak. It is an incredibly organized, infinite filing system.
That takes us to our fourth section, symmetries of the field, and how this whole architecture stays balanced.
You might be wondering, with all this infinite scaling motion, how does the prime field keep from just flying apart? Well, it's kept in check by four incredibly powerful mathematical symmetries. First, we have the internal field mirror. For instance, 1 and 29 balance each other out perfectly to equal our boundary of 30. Then we have layer reflection across adjacent fields, which balances things out to 60. Next up is translational recurrence, which just repeats this pattern infinitely. And finally, crucially, we have seam symmetry. This is where the whole puzzle just beautifully clicks into place. The number 15, modulo 30, sits dead center in our face. It acts as the grand central balancer, nesting perfectly between the innermost P1 prime candidates, 13 and 17. Because 15 is exactly half of 30, this seam miraculously stabilizes every single scaled disturbance created by those prime roots as they multiply into infinity. It is literally the architectural anchor for the entire universe of numbers.
And finally, the grand finale, Section 5, the Riemann critical line, bridging everything to infinity.
Let's contrast these two incredible concepts side by side. On the prime field side, our central stabilizing seam generates a clean ratio, 15 over 30, which neatly reduces to 1/2. Now look over at the analytic zeta side, the incredibly famous Riemann critical line, where the solutions to arguably math's biggest unsolved puzzle supposedly lie, is located exactly at the real part of 1/2. This is huge. It illustrates a direct structural bridge between the integer field center we literally just built together and the highly complex analytic Riemann critical line. They share the exact same central compulsion.
When you pull it all together, the prime field architecture makes a super compelling, neutral case for a unified mathematical blueprint. Our P1 lane filters the prime candidates, which perfectly aligns with the Euler product encoding. That's the foundational formula linking prime numbers together. On top of that, the multiplicative expansion of roots is perfectly canceled out by mirror symmetries, and the whole shebang compels a critical center firmly anchored right at 1/2. It strongly implies that the Riemann hypothesis isn't just some weird quirk of complex analysis, but a perfect, literal reflection of the geometric balance of the integers themselves. Infinity is less an unbounded quantity and more a self-preserving structural process. I want you to let that profound thought from the research sink in for just a moment. The universe of numbers doesn't just stretch out into a random void. It actively preserves itself through these perfectly recurring operations, balances, and symmetries. So I'm going to leave you with this awe-inspiring question to ponder. Is infinity just a consequence of a perfectly balanced, repeated operation? We've seen exactly how the boundary of 30 creates a machine that runs forever without ever losing its center. I really hope this explainer has completely changed how you view the infinite blueprint of mathematics, and that it leaves you eager to explore more of its hidden architecture. Until next time, keep exploring.